And hello, everyone. So I wanted to talk about a project that we had at Inmarsat called Fleet Edge Voice. So Fleet Edge is a platform, a maritime platform on board a vessel, and we wanted to add enhanced voice features for the customers there. So to paint a picture about Inmarsat, in case you don't know who Inmarsat is, we've been in the business of satellite connectivity for over 40 years, serving a variety of markets, including maritime and aviation. I work in the maritime area. And we have a fleet of geostationary satellites offering voice and data and the safety services that were the reason that Inmarsat was created in the first place. So we have 14 geostationary satellites at the moment. So to give a flavor of the kind of projects that are running inside Inmarsat, so we have Orchestra, which has been widely talked about in the media, which is this idea of bringing together many different types of connectivity, not just satellite, but also 5G and mesh networks. And that will continue for the next many years. It's a huge scope. And GX10 is an exciting new satellite for us, which is going to, it's in a highly eccentric orbit covering the poles, or covering the North Pole and the high latitudes. So it's filling in gaps that can't be covered by the geostationary satellite. Because if you can imagine the Earth, if you have a geostationary satellite, it's very far away, so it's looking side on to the Earth. So by the time you get to the North Pole, the satellite is always extremely low to the horizon. So GX10 will be to counter that. And Inmarsat 6 was launched last December. It's just coming up into its selected orbit now. It takes a long time to get it into the right place. And as we speak, tests are going on, the onboard system tests for a switch on in the next few weeks. And to give an idea of scale, that is the i6 F1 when it was in the factory prior to being put into its fairing to be mounted on the rocket. You can see the technicians at the bottom are quite small in comparison to the satellite itself. So to understand something about the services that we have in Inmarsat, so we have two different broadband services. So the L-band services, known as BGAN, they run in satellites that have been launched since 2005. So it's quite an old service now, but still very suitable for maritime applications. And then we have a newer service called Global Xpress, or GX. So those satellites went up from 2013 onwards. In fact, the i6 F1 that I just showed has both those services on board. So the difference between those services is that GX is a much faster service, but BGAN is a more resilient service. So because GX is in a much higher frequency band, the Ka band is sort of 26 gigahertz. It's much more affected by the atmosphere and weather conditions. So if you're in a storm, you experience what's called rain fade. So the signal is very attenuated, perhaps even can't be received at all, in which case it's desirable to use the BGAN service. And many vessels have both services on board, so they can pick and choose. And to show how Fleet Edge fits in, so on the right-hand side there, we have a marine vessel, and it has a rack on board, very similar to what you would see in a shoreside data center. So there's a 1U PC in there. There are switches, routers, and antenna control units for the satellite. So you need quite a big space for it, but these are mainly installed on large vessels. And so the vessel can communicate over GX or BGAN to the shore. So you see on the left-hand side there, we have our downlink, our satellite base station. And so we have our support services running in AWS and EKS. A lot of this is containerized and runs in Kubernetes. So on the shore side, we have the packages that are needed to support the vessels, and so that we can do remote control and so on. And then just below that, you'll see there's also the PSTN link. So we use a big software switch called MetaSwitch. So that's our VoIP switch, and it also interconnects with all the other PSTN services across the world. So, so a summary of Fleet Edge. So it's like a small data center on a ship. So the PC that we have there has a number of different environments, VMs on that machine, and some of those also have containers on them that run different services. So we can host customers' applications as well as our own applications. And this is one of the main reasons that Fleet Edge exists, because in many cases the owners of the vessels don't want to maintain and run their own machines, so that this is a service that we offer them. And we have the voice service on board as well, which is, you know, we're enhancing as part of this Fleet Edge voice project. Importantly, we have over-the-air configuration, so it's possible to use APIs on the shore to directly configure the machines, and we can also we can send Fleet Edge a message and tell it that a new version of a new software build is available, and then it's able to find out to get a manifest of all of the components that have changed and actually download software over the air. And then finally at the bottom there we have assurance, which is to say, you know, this is a stream of metrics from various parts of the system that are sent on a regular basis that go into a special database on the shore that can be accessed by the customers. So for example, you can get the GPS location of the vessel and you can get the performance level of the satellite systems and so on. And we have logging, which is, you know, helps us to diagnose problems that customers are experiencing. So looking at Fleet Edge Voice, so we chose the G729 codec for our voice support because we have limited bandwidth. We want to get as many voice channels as we can connected. On BGAN, you can support 5 concurrent voice calls. In GX, it's much more, but we need to conserve the bandwidth, so we use G729. And also G729, because it's been around for a long time, is supported by a whole range of other equipment. So G729 was already built into our MetaSwitch on the shore, and it also happens to be the codec that is used by a lot of customer equipment. And with Fleet Edge Voice, we wanted to have rapid over-the-air deployment. So we can send a small blob of JSON data via an API on the shore, and within a few minutes, that will have reconfigured Fleet Edge. And so we can dynamically change the DDI numbers that are available on the vessel. And another important feature is this failover. So as I mentioned, you can get problems with GX in poor weather, and so we built in the ability to run on GX, but then in the case that GX was not available, it could fall back onto BGAN, and to do that we need to reprogram the dial plan in order to make Freeswitch behave in a different way depending on the resources that are available. So this is kind of the philosophy of Fleet Edge Voice. So you see on the left-hand side there, we have a routing and QoS component, which is connected to the control systems of the satellite terminals. So it can instruct the satellite terminals, and it can receive data from the APIs there. And then you see that in turn is interconnected via MQTT, which is a message bus, a two-way message bus. And I'll talk a bit more about that in a minute. So that allows conversation with Freeswitch for control signals. And of course, we have SIP and RTP, so that's the path where the voice calls will go over the satellite link and into our meta switch, and then potentially switched out into the outside PSTN. So obviously, Freeswitch allows us to directly register clients. So you can have soft phones or SIP phones which register with Freeswitch, and that was the first phase of the project. But then we wanted also to be able to adapt to equipment that customers already have. So in many cases, value-added resellers have their own PBXs, their own phones, and their own stuff that they want to install on the ship. In which case, all they want from us is a SIP trunk that will support the DDI numbers that they've been given within their environment. So to look at how we implemented this, so typically the way that we interact with Fleet Edge from the shore is we use Ansible. So we execute Ansible scripts over a secure link to the Fleet Edge. And in this case, we're also making a lot of use of Ginger. So Ginger is a scripting language that works alongside Ansible, and it allows you, while you're copying files, to do substitutions and manipulations in the text as part of the push operation, which is a very powerful capability that we're using here. And I'll show you some examples of that. So MQTT I mentioned before. So we created this component called Quokka, and Quokka sits on top of the Freeswitch API, the ESL API, and it does some translation and filtering, and it forwards the messages to MQTT. So MQTT was a component that we already had on board the Fleet Edge. It's used for inter-environment communication, for example, with the assurance metrics. And so in the very specific case of Fleet Edge Voice, we have this two-way communication because the routing and QoS component knows whether we're currently switched to GX or BGAN. So it can communicate that information to Freeswitch. And on the flip side, Freeswitch knows how many calls are currently connected, and it communicates that to routing and QoS, because that allows us to reprogram the satellite terminal and get the best quality of service for the number of calls that we've got. And this allows us to have the dial plan being very dynamic and changing its behavior depending on which satellite system we're connected to. So some of the challenges that we experienced during this project, we have a very complex networking environment on the Fleet Edge. It has the different VMs and containers, and there are lots of different loopback IP addresses. So we did have some challenges making sure that the invite advertised the correct loopback interface to make sure that we could actually get the calls working. So in the early days we did have one-way audio, and for a period we had problems with SIP ACK timeouts because we were losing an ACK, which meant that the voice call would only be connected for 30 seconds. And also it was challenging getting all of the different customer requirements into one set of template files that we could use as the basis for the Freeswitch configuration. So having got the original registration configuration in place, we then needed to support the SIP trunk system, which took a few more weeks to understand exactly how we were going to build that. but it came good in the end. And actually, we were able to take part in another project that was going on in Inmarsat at the time called rack simplification. So that allowed us to take out a Cisco router that had previously been used for supporting customer equipment. And we pulled all of that functionality into the software configuration of Freeswitch. So it actually ended up saving not only money, but because of the chip shortage after the pandemic, we were having problems sourcing some of the equipment that we needed. And so being able to exclude a piece of hardware was extremely valuable. And of course, on the subject of the pandemic, you know, while we were working on this, we were all sent home, and the culture of Inmarsat had always been a very much working in the office type of thing. So this is quite momentous for us because everybody went home and we started using Teams. But in the end, we were quite productive, and we managed to deliver this and other projects during the pandemic. So to give a technical flavor of how some of this works, so an example of the Ginger that we have here, if you look down on about line 3, so we have a for loop there. So when we say for client in clients, clients is actually one of the fields in our JSON blob that we send over the API. So what this is doing is identifying all of the client lines within the configuration. So each one of those has a DDI number, which we need to pull into our Freeswitch configuration. And you also see that we're checking, was that line 5? We're checking if BGAN is named as one of the flags on a particular line. And what that means is that number will have special treatment. So if you have the BGAN flag, it means that when the system switches over from GX to BGAN, and you've only got 5 calls available, you can choose certain numbers that will preferentially, you know, be able to get those numbers and still be active, you know, during the storm at sea. And you see at the bottom there, the output of this is actually a regex. So we're creating a regex, which is then going to be referred to in the Freeswitch dial plan. And then this is what we're doing with the information about whether we're currently switched to GX or BGAN. So down on about line 4 there, you see we're looking at this variable called satellite link. So there we're making a decision on whether the system is currently switched to BGAN or GX. So when this dial plan is evaluated, we can use the knowledge of whether we're switched to BGAN currently or on GX, and we can implement a different kind of dial plan. So we can dead-end calls if we want to, and we can prioritize numbers that have the BGAN flag on them. So I'd just like to pay tribute to my colleagues in Inmarsat who helped me build this from the first glimmerings of imagination. And thank you to all of you for turning up to this in-person ClueCon. It's certainly very good for me to be able to come here and tell my story.
Have applause. Thank you so much for being here. Do we have any questions from the audience? Got one right here in the center.
Yeah, I was wondering, when you do the switch from XP to BGAN, did you also have to do shoreside changes to accommodate maybe the IP routing or things like that, or is that already accounted for?
No, it wasn't necessary to make a change there. We already had that capability. Yeah, thanks.
Another question right over here.
Thank you. Hi, does the SIP message convey any GPS coordinates?
No, so we send GPS to the shore via assurance, so it's part of a different system. Is there a reason that would be useful? All right.
Anyone else? Any other questions? All right. Big round of applause. Thank you
Thank
so
you very
much.
much.